68 million BC, Alaska's icy expanse was home to a chilling predator, Nanuqsaurus, the polar tyrannosaur. Imagine glowing eyes piercing the Arctic twilight, nostrils flaring as it catches your scent. This isn't fiction, it's a scientific marvel. With unique adaptations to survive harsh conditions, Nanuqsaurus thrived where others couldn't. Ready to uncover the secrets of this remarkable Arctic predator? In 2006, paleontologists made a remarkable discovery in the frozen tundra of Alaska's North Slope. A collection of fossilized bones, initially thought to belong to a juvenile Gorgosaurus or Albertosaurus, emerged from the icy ground. As the team carefully extracted the specimens, they realized they were dealing with something extraordinary. The fossils exhibited subtle yet significant differences from other known tyrannosaurs. Skull fragments displayed distinctive features, and the bones were smaller than expected for an adult Gorgosaurus, yet showed signs of mature growth. This paradox spurred researchers to investigate further. Years of meticulous study followed. Scientists compared the Alaska specimens to tyrannosaur fossils from lower latitudes, examining every ridge and groove. They analyzed the internal structure of the bones, seeking clues about the animal's growth and lifestyle. With each piece of evidence, the picture of a unique Arctic predator emerged. In 2014, after rigorous study and peer review, the scientific community welcomed Nanuqsaurus hoglundi to the tyrannosaur family. The name, derived from the Inupiat word for polar bear, and honoring philanthropist Forrest Hoglund, perfectly captured the essence of this Arctic predator. The classification of Nanuqsaurus as a distinct genus forced scientists to reconsider their understanding of tyrannosaur evolution and adaptation. How had this creature managed to thrive in an environment that would have been challenging even for warm-blooded mammals? Nanuqsaurus wasn't simply a scaled-down version of its famous cousin, Tyrannosaurus rex. It was a finely tuned predator with adaptations that allowed it to dominate the harsh Arctic ecosystem of the late Cretaceous period. From its potentially enhanced senses to its compact size, every aspect of Nanuqsaurus demonstrates evolutionary ingenuity in the face of extreme conditions. When picturing a tyrannosaur, most envision a massive, terrifying predator. However, Nanuqsaurus challenges our preconceptions about these ancient hunters, proving that in the world of dinosaurs, size isn't everything. Tyrannosaurs are typically characterized by their enormous size, powerful jaws, and tiny arms. But Nanuqsaurus hoglundi broke this mold in surprising ways. Initially estimated to be around 20 feet long and weighing about 1,000 pounds, recent studies have revealed that this Arctic predator may have been more substantial. New evidence suggests Nanuqsaurus could have reached lengths of up to 30 feet and weighed around 3 tons, making it one of the largest predators in its frigid domain. The skull of Nanuqsaurus, measuring between 24 and 28 inches long, tells a fascinating story of adaptation. It featured unique characteristics that set it apart from other tyrannosaurs, such as a thin, rostrally forked median spur of the fused parietals and a long, rostrally pointed process of the frontal. These distinctive features hint at Nanuqsaurus's specialized lifestyle in the harsh Arctic environment. One of the most intriguing aspects of Nanuqsaurus is its dental adaptations. Unlike other tyrannosaurids, the first 2 dentary teeth were much smaller than the subsequent teeth. This unusual arrangement may have provided advantages in hunting or feeding that were particularly suited to the polar region. The unique adaptations of Nanuqsaurus paint a picture of a predator perfectly suited to its environment. Its smaller size would have allowed it to navigate through the Arctic landscape more easily, while its robust build and specialized skull features ensured it remained an efficient hunter. The harsh conditions of the polar region likely favored a predator that could effectively utilize limited resources, and Nanuqsaurus seems to have fit this niche perfectly. As we continue to unravel the mysteries of Nanuqsaurus, we gain a deeper appreciation for the incredible diversity of tyrannosaurs. This Arctic hunter demonstrates how evolution can produce surprising solutions to environmental challenges. In the next section, we'll explore the ancient Arctic ecosystem that Nanuqsaurus called home and discover how this unique predator fit into a world of ice and twilight. The Arctic winter posed a daunting challenge for Nanuqsaurus, marked by the polar night, 4 months of total darkness each year. While the late Cretaceous Arctic was warmer than today, it still endured long, sunless winters with average temperatures plummeting to -10 degrees Celsius. Without sunlight, plants halted photosynthesis, disrupting the food chain and limiting resources for survival. To endure such extremes, Nanuqsaurus likely developed remarkable adaptations. Drawing parallels with modern Arctic predators, it may have honed advanced sensory abilities to hunt in low-light conditions. Although its specific skeletal adaptations remain unclear, scientists theorize that Nanuqsaurus might have evolved a compact body with shorter limbs, similar to Arctic mammals today, to conserve heat in frigid conditions. One of its most intriguing traits was its potential sense of smell. Evidence suggests that tyrannosaurs possessed highly developed olfactory bulbs, comparable to modern bloodhounds. For Nanuqsaurus, this ability may have been even more critical, enabling it to track prey by scent alone during the polar night. This adaptation, combined with other possible physical traits, underscores its mastery of its Arctic habitat. Yet mysteries linger about its diet and hunting strategies. What prey sustained Nanuqsaurus during the dark winters? How did it dominate its frozen ecosystem? By examining the ancient Arctic food web, we can unravel the unique survival strategies of this polar predator and its role in a dynamic prehistoric ecosystem. Imagine a land where towering hadrosaurs roam alongside armored ceratopsians, their footsteps echoing across a landscape that endures months of darkness each year. This was the world of Nanuqsaurus. The Prince Creek Formation, where Nanuqsaurus fossils were discovered, reveals a diverse ecosystem teeming with life. Edmontosaurus, a large duck-billed hadrosaur, grazed on the abundant vegetation. Smaller predatory theropods like Troodon and Dromaeosaurus darted through the undergrowth, adding complexity to this prehistoric food web. Evidence suggests that ankylosaurs and small mammals also inhabited this polar region, contributing to the rich biodiversity. For Nanuqsaurus, this diversity presented both opportunities and challenges. As an apex predator, it required substantial food to fuel its body, especially in an environment where temperatures could plummet below freezing. To overcome these obstacles, Nanuqsaurus likely employed specialized hunting strategies. Its smaller size compared to its southern relatives may have been a key adaptation, allowing it to maintain agility while requiring less food. This reduction in size didn't diminish its ferocity, however. With a powerful bite force and sharp teeth, Nanuqsaurus was well equipped to take down large herbivores. Evidence suggests that Nanuqsaurus primarily targeted the abundant hadrosaurs in its environment. Tooth marks found on herbivorous dinosaur bones in the Prince Creek Formation indicate active predation by large theropods like Nanuqsaurus. These marks reveal violent encounters between predator and prey, with Nanuqsaurus using its strong jaws and serrated teeth to deliver devastating bites. Nanuqsaurus likely shared hunting behaviors with its relative Gorgosaurus, but its Arctic adaptations set it apart. With an enhanced sense of smell and possible low-light vision, it excelled in tracking prey during long polar nights. These traits, paired with potential pack hunting, secured its place as a dominant predator. Despite being smaller than Tyrannosaurus rex, Nanuqsaurus was equally lethal, its unique adaptations making it a formidable hunter. Thriving in the harsh Arctic, it shaped its ancient ecosystem, showcasing life's remarkable adaptability. Exploring its physical traits reveals how this tyrannosaur endured the frigid cold and perpetual darkness of its icy domain. In the frigid expanse of the Arctic, where temperatures plummet far below freezing, the discovery of a tyrannosaur like Nanuqsaurus challenges our preconceptions about dinosaur adaptations. The harsh environment of the Cretaceous polar regions demanded specialized traits for survival, and Nanuqsaurus likely possessed a suite of remarkable features to thrive in these conditions. Recent research suggests that many dinosaurs, particularly theropods like Nanuqsaurus, may have had metabolisms more similar to modern birds than to reptiles. This insight is crucial when considering how this predator coped with the extreme cold of its habitat. While no direct evidence of feathers has been found for Nanuqsaurus itself, its close relative Yutyrannus provides compelling clues. The discovery of extensive primitive feathers on Yutyrannus has led paleontologists to hypothesize that many tyrannosaurs, including Nanuqsaurus, may have sported similar coverings. For an Arctic dweller like Nanuqsaurus, feathers would have been more than mere ornamentation. They likely played a vital role in insulation, potentially featuring specialized structures for trapping heat. The feathers might have been denser or longer than those of its southern relatives, providing superior protection against the biting cold. Additionally, the arrangement of these feathers could have created air pockets, further enhancing their insulating properties. Beyond feathers, Nanuqsaurus likely possessed other cold weather adaptations. Its body may have been more compact than other tyrannosaurs, reducing surface area and conserving heat. Specialized circulation in its legs and feet, akin to countercurrent heat exchange systems in modern Arctic animals, could have helped maintain body temperature even when standing on frozen ground. These adaptations would have allowed Nanuqsaurus to remain active year-round, even during the darkest and coldest months of the Arctic winter. The potential for a fully feathered, cold-adapted Nanuqsaurus transforms our understanding of this polar predator. Such features would have enabled it to thrive in conditions that would challenge even modern warm-blooded animals, highlighting the remarkable adaptability of these ancient creatures. As we continue to unravel the mysteries of Nanuqsaurus, we're left to consider how its size played a role in its survival strategy. How did the dimensions of this Arctic tyrannosaur compare to its southern relatives? And what advantages did its size confer in the frozen north? The answer may lie in the Goldilocks principle of Arctic survival, where Nanuqsaurus found its perfect fit in a world of extremes. When it comes to Arctic survival, Nanuqsaurus challenges our assumptions about what it takes to thrive in one of Earth's most unforgiving environments. This polar tyrannosaur was significantly smaller than its famous cousin, Tyrannosaurus rex. The reduced size of Nanuqsaurus likely reflected a phenotypic response to the seasonal climate of the ancient Arctic. This adaptation mirrors what we see in modern carnivores living in insular settings, where limited resources often lead to smaller body sizes compared to their mainland relatives. For Nanuqsaurus, this smaller stature would have been particularly beneficial during the long Arctic winters, when prey availability was at its lowest. The key to Nanuqsaurus's success lay in the relationship between body size and energy requirements. Smaller animals require less energy to maintain their bodily functions, a crucial factor for survival in a resource-scarce environment like the Arctic. During periods of food scarcity, particularly the extended polar nights, Nanuqsaurus's more modest size would have allowed it to survive on fewer calories than a larger tyrannosaur. By striking the perfect balance between size and energy requirements, this polar tyrannosaur was able to exploit available food sources in a way that larger predators simply couldn't match. Nanuqsaurus highlights the incredible diversity of tyrannosaurs and the power of adaptation in extreme conditions. This Arctic predator thrived not by size, but by mastering its unique environment. Yet mysteries remain. Did it endure the harsh Arctic alone, or find strength in numbers? Investigating its social behavior could unveil whether pack hunting played a key role in its survival strategy, adding another layer to its remarkable story. In the harsh world of the Cretaceous Arctic, survival often hinged on unexpected adaptations. For Nanuqsaurus, social bonds may have been crucial to conquering this unforgiving realm. As we piece together clues from fossils and modern animal behavior, a surprising picture of tyrannosaur life begins to emerge. The question of whether Nanuqsaurus hunted alone or in packs has long intrigued paleontologists. This debate extends beyond our Arctic tyrant to encompass the social behavior of tyrannosaurs as a whole. While the popular image often depicts solitary hunters, recent evidence suggests a more complex reality. Tyrannosaur fossils discovered in group settings have led some researchers to propose that certain species may have engaged in pack hunting. For Nanuqsaurus, living in the resource-scarce Arctic environment, such cooperative behavior might have been particularly beneficial. Pack hunting could have allowed these predators to tackle larger prey, such as the formidable Tyrannosaurus, with greater efficiency. However, the limited resources of the Arctic environment would have made it difficult to sustain large groups of apex predators. Competition for food within the pack could have been fierce, potentially leading to conflicts that might have outweighed the benefits of cooperation. Modern Arctic predators like wolves provide intriguing parallels that might shed light on Nanuqsaurus behavior. Wolves form packs that enhance their hunting success and survival in extreme conditions, suggesting similar strategies could have benefited Nanuqsaurus in its icy domain. The high juvenile mortality rates observed in Nanuqsaurus fossils indicate that young individuals faced significant challenges. This could potentially support the idea of social structures or pack behavior, as group living might have provided additional protection and food-sharing opportunities for vulnerable juveniles. The social structure of Nanuqsaurus remains speculative, but intriguing theories suggest it may have displayed flexible behaviors, forming temporary hunting groups during abundant periods and dispersing in scarcity. This adaptability highlights its ability to thrive in the harsh Arctic. Whether hunting solo or in packs, Nanuqsaurus demonstrated remarkable strategies for survival. To understand how these predators grew and thrived in such extremes, we delve into their life cycle, from vulnerable hatchlings to dominant Arctic apex predators. The Arctic posed a formidable challenge for young Nanuqsaurus, with the scarcity of juvenile fossils highlighting the difficulties these dinosaurs faced. Many never reached adulthood, succumbing to the harsh Cretaceous polar environment. The Prince Creek Formation, where Nanuqsaurus fossils were unearthed, offers clues to their survival struggles. It contains a high proportion of juvenile dinosaur remains, shedding light on low survival rates in the Arctic. Long, dark winters and scarce food created significant hurdles for young dinosaurs. Nanuqsaurus likely laid its eggs in April, aligning hatching with the brief Arctic summer. This strategy provided a short window of milder weather and increased resources, critical for hatchling survival. Still, the odds were daunting, as the first year was particularly treacherous. Many juveniles struggled to find enough food to endure their first winter, reflected in the abundance of juvenile fossils indicating high mortality during this period. Despite these challenges, some young Nanuqsaurus reached adulthood, likely due to rapid growth rates and specialized Arctic adaptations. Like other tyrannosaurs, they may have experienced accelerated growth in their early years, improving their resilience to harsh conditions and enhancing their ability to compete for limited resources. Though evidence of parental care in Nanuqsaurus is absent, studies of related theropods suggest that some parental investment, such as nest protection or feeding hatchlings, may have occurred. Such care could have improved survival odds during the most vulnerable stages of life. As juveniles grew, they faced new challenges, including competition with adults for food. This likely pushed younger Nanuqsaurus to adopt alternative hunting strategies or focus on smaller prey. These adaptive behaviors helped shape their role as Arctic predators. The scarcity of juvenile fossils provides a glimpse into the life of these resilient dinosaurs, emphasizing the struggles and adaptations that allowed some to thrive. The survival of Nanuqsaurus, both young and mature, profoundly impacted the Arctic ecosystem, influencing its dynamics and balance. The story of Nanuqsaurus's life cycle, from vulnerable hatchlings to apex predators, reveals the resilience of life in extreme environments. These remarkable creatures left an enduring mark on their ancient world, offering a compelling chapter in the story of dinosaur evolution. Nanuqsaurus was more than just an impressive hunter. This Arctic tyrannosaur actively shaped its ecosystem through a variety of complex interactions. Its presence exerted significant pressure on herbivorous dinosaurs like Tyrannosaurus, forcing them to adapt their behavior and physical characteristics. Prey species likely developed new foraging strategies, altered migration patterns, or favored vegetation that provided better cover from the tyrannosaur's keen eyes. The hunting activities of Nanuqsaurus had far-reaching effects on the local food web. Its dietary preferences and hunting strategies influenced not only prey population dynamics, but also those of competing predators. Smaller carnivores might have adjusted their hunting patterns to avoid confrontation with the dominant Nanuqsaurus, creating a complex network of predator-prey interactions across the Arctic landscape. Fossil evidence suggests that Nanuqsaurus occupied a dominant position in its ecosystem. This apex predator likely contributed to nutrient cycling through its hunting activities, similar to the role of modern Arctic predators like polar bears. The absence of Nanuqsaurus from the late Cretaceous Arctic ecosystem could have led to significant ecological imbalances, potentially altering plant communities and ecosystem structure. The discovery of Nanuqsaurus fossils in the Prince Creek Formation has provided valuable insights into the complexity of Arctic ecosystems during the late Cretaceous. This tyrannosaur's influence extended to every aspect of its environment, from prey behavior to nutrient cycling. As we continue to study Nanuqsaurus and its world, we gain a deeper understanding of the intricate connections within prehistoric ecosystems. The story of this Arctic tyrannosaur demonstrates the profound impact a single species can have on its environment. However, the reign of Nanuqsaurus would not last forever. To understand its ultimate fate, we must examine the twilight years of this formidable predator and the changing world that would seal its destiny. The late Cretaceous period marked a time of significant environmental change for the Arctic region. As the climate shifted and ecosystems transformed, Nanuqsaurus faced unprecedented challenges in a rapidly changing world. The once stable greenhouse conditions gave way to more unpredictable weather patterns, with temperatures fluctuating dramatically between seasons. This shift had far-reaching consequences for the entire Arctic ecosystem, altering plant growth, and by extension, the entire food chain that supported this apex predator. Nanuqsaurus, like all tyrannosaurs, had evolved to be a highly specialized hunter. Its adaptations, from its enhanced sense of smell to its potentially feathered coat, had allowed it to dominate in the harsh Arctic environment for millions of years. However, as the climate shifted, these very adaptations may have become liabilities. The changing ecosystem likely altered the availability and behavior of prey species, forcing Nanuqsaurus to adapt its hunting strategies or face starvation. Competition intensified as the environment changed. Nanuqsaurus found itself competing for increasingly scarce resources, not only with long-standing rivals, but potentially with new species moving northward as temperatures shifted. This added pressure tested the limits of its adaptability and resilience. As the end of the Cretaceous period approached, the challenges facing Nanuqsaurus intensified. The gradual cooling trend, coupled with more extreme seasonal changes, put immense pressure on the Arctic ecosystem. Prolonged periods of darkness during winter became even more challenging as food sources dwindled. The fossil record reveals high mortality rates, particularly among younger individuals, suggesting a disruption in population dynamics that threaten the species' long-term survival. Current theories suggest that Nanuqsaurus, like many other dinosaur species, may have gone extinct before the catastrophic end Cretaceous event 66 million years ago. The combination of climate change, shifting ecosystems, and increased competition likely proved too much for even this highly adapted Arctic predator to overcome. The exact timing and cause of Nanuqsaurus's extinction remain a subject of ongoing research and debate. As paleontologist Anthony Fiorillo noted, "We still don't know how they survived an Arctic year," highlighting the ongoing mystery surrounding the adaptations and ultimate fate of this remarkable creature. The story of Nanuqsaurus serves as a powerful reminder of the delicate balance between adaptation and extinction, a balance that continues to shape life on Earth to this day. Nanuqsaurus showcases the remarkable adaptability of life in extreme conditions. Thriving in the ancient Arctic, it offers profound lessons on resilience and evolution. Its story not only highlights the impact of environmental shifts, but also underscores nature's capacity to adapt. As we uncover more about this polar predator, Nanuqsaurus stands as a reminder of Earth's evolutionary marvels and the intricate relationship between species and their ever-changing environments.